Hello and welcome to this Active Reach technical tutorial video. We're going to have a look at HSRP today. We've got a topology here with a host connected to a switch, and we've got two routers on the network. We've got router 1 and router 2, 10.221 and 10.222. And I've statically configured the host with 10.22100. And at the moment you can see our host device can reach both these routers. And that currently there's no access out to the internet, but I have set up these routers to NAT out, and if we were to set our route out via router 1 in configuration mode, obviously, then we would be able to ping out to the internet, hopefully. There we go. Or we could change that to router 2. So let's take that out and change it to router 2. And we can get out that way as well. So you can see that it's possible to get access out to the internet via a default route through either router 1 or router 2. But if we want to add proper redundancy to our network and have a failover mechanism, we can create an HSRP group running between those two routers. So if one went down, hosts on the network would automatically be able to use the other one. And that's what we're going to use HSRP for, which is a first hop redundancy protocol. HSRP stands for Hot Standby Router Protocol. So let's go back onto our host, and we're going to change the IP route. So let's take that one out, and we're going to make the IP route our HSRP address, like so. And at the moment, of course, that won't work because we don't have 10.2.2.254 on our network. So let's jump onto router 1 and rectify that. So this is router 1. And we want to go into configuration mode, and we want to configure this interface with HSRP. So we go into interface fast Ethernet. And we are going to say standby 1. So we need to give it a group number, which can be anything from 0 to 255. I don't know why you'd want so many groups, but we'll just give it a standby group 1, and we want to give it an IP address 10.2.2.254. And that really is it. This router will now start listening to multicast packets on the HSRP version 1 multicast. It's using version 1 here, and it will first of all start initializing, and then it will start listening. So it's now listening to multicast packets on that group. Once it's finished listening, it will then speak. So HSRP is a polite protocol, if you like. It listens first, then it speaks, and if it hasn't heard anything and nothing else decides to be the active router on its standby group, so it's only listening on this group here. You can put it into multiple groups if you want. We're just going to be configuring for a single group. You can see that now this router has become the active router on this HSRP group, because there is no other routers at the moment in the same group. Standby router is unknown, and if we go back onto our host now, we can see that it should hopefully be able to ping out. And it can. And we have an ARP entry for 10.2.2.254. So we know 10.2.2.254 is actually this router here. And it's got a special MAC address. This MAC address is a reserved MAC address for HSRP. So when you see a MAC address beginning with these characters, you'll know that it's an HSRP MAC address, and it just puts the HSRP group as the last two digits on the MAC address. So it's a 0, 1. So let's join router 2 to our HSRP group. Go into configuration mode. Just do a quick show IP int brief. Oh, sorry. And we can see there this is router 2 on 10.2.2.2. So we're going to be joining this router, and it's going to join this HSRP floating IP. So we go into that interface, and we're going to be putting it in the same group. If you put it into a different group, it won't join the same HSRP group, and it won't work. So we have to make sure this number matches the group we're trying to join. Standby 1 IP, sorry about that. And there we go. And if we have a look at show standby on this, you'll see it goes through the same process. It's going to go through initialization, then it's going to listen, and then it's going to speak, and then, if all goes well, it's going to take over the role of the standby router. There we go, standby router is local. So router 2 is now the standby router, and router 1 is the active router in this HSRP group. So now hopefully what will happen is if router 1 goes down on the network, our host will still be able to operate. So let's run a ping out to the internet. Let's just run it for 5,000, and let's see what happens when we reboot router 1. So I'm just going to use another device here to jump onto router 1. And we're just going to reload it. We didn't save the config, but it should prompt us. So yeah, there we go. Okay, so that router is going to start rebooting now. There we go, that's rebooting, and there we go. Our host, I'll just stop these pings. Our host had a blip here, but then it carried on. So very, very short blip on our network traffic, almost nothing. Hopefully no one would really notice that in the real world. And if we have a look at the ARP table, the ARP entry is the same. 10.2.2.2.254 is our default gateway out, and the MAC address is the same. So that's how HSRP works. It creates this floating IP address, this floating MAC address, and when one router goes down, the other one takes over that same function. So let's jump onto router 2, which should now be our active router on our output. There we go, active router is local, and currently the standby router is unknown, because router 1 at this stage is still rebooting. Now have another look at another output here. I'll show you standby brief, which is quite a good output. We can see here, this gives us a nice output, which shows us which interface it's running on, which group it's participating in, the priority, whether or not it is got preempt enabled. You might want router 1 to take over the active role when it comes back up, and if you enabled preemption on the router, then that is what it would do. It would take over the active role when it comes back up. But its default state on HSRP is to have preemption disabled. So when router 1 comes back up, router 2 should remain the active router, and router 1 will take on the standby role. And let's just wait and see Now you see the standby router was unknown, and now router 1 must be back up because it can now see the standby router has appeared here. So if we go back onto router 1, there we go, and have a look at the show standby output. There we go, the state is now standby, and the active router is router 2, and this router is the standby router. So we can see it working in all its glory there, and we had a very short blip on our network while the HSRP figured out how to switch the routers over. But we've got ourselves a nice redundant topology. So we've got this is a first hop redundancy protocol. We've got our 2 routers in the HSRP group. When one goes down, the other one can take over as the gateway for hosts on our network. And you might have, I mean, we statically assigned the host with an IP address on this network. You might have it as a DHCP device. So if hosts are picking up a DHCP address from the router, then that can be done, but it's not really wise to run DHCP and HSRP on the same device like that. Because if you imagine you picked up an IP address from router 1 in this pool, and then router 1 goes down, then the host will still be able to communicate on the network. But when if another device joins the network, you could end up with an IP conflict, because router 2 won't be the lease for the IP address that the host has been given. And then that means router 2 might give out the same IP address to a different host on the network. So to get around that, what you can do is you can split the pools in 2 and make sure router 1 has a different pool to router 2. So if router 1 goes down, the host would still work, but IP addresses would be given out on a different range, or on a different pool, and therefore you wouldn't have IP address conflicts on your network when the routers are flipping between active and standby. But that's not particularly efficient, because you're effectively halving your IP, the amount of IP addresses on your network. Really, what you'd want is to have your DHCP server separate from your HSRP devices. That would be the best topology to have. So there's a quick look at HSRP and how that can help you have first hop redundancy on your network. So HSRP version 1 uses the multicast address of 224.0.0.2 when it is listening and when it's speaking to other HSRP devices. HSRP version 2 is also available now, which has more groups available, and it uses a different multicast address of 224.0.0.1.0.2, and it also supports IPv6. And you can't have one of your routers running HSRP version 1 and the other running HSRP version 2. They will not play nicely together if you do that. You have to be running the same version. So just remember, you can't mix the versions of HSRP. And the alternative to HSRP is VRRP, which is Virtual Redundancy Router Protocol or something. And that is the non-Cisco proprietary version of this. And that uses a different multicast address as well as a different floating MAC address. So this is the floating MAC address used for HSRP. VRRP uses a multicast address of 224.0.0.18 and also a different MAC address format. All worth knowing if you come across this in the real world. So that's a quick look at HSRP and how you can use that to add redundancy to your network. I hope that's been useful to you. Thank you very much for watching.